Hello, I am John David Prieto Prada from Digist in Daegu, South Korea, and I would like to share the results of our work titled A Gaze-Speech System in Mixed Reality for Human-Robot Interaction. The human-robot interaction field has evolved over the years to help humans to resolve different tasks. During HRI tasks, time performance is a critical variable that requires attention. Time performance in industrial processes is a challenging factor frequently influenced by how the users interact with the robot. However, immersive methods have shown improved time performance during HRI tasks. Regarding immersiveness, some studies have used mixed reality methods in HRI tasks. However, MR methods in HRI have promising potential and require more improvement in terms of time performance. We proposed a gaze-speech system that effectively enhances time performance in HRI tasks through MR. To our knowledge, this is the first attempt to use an MR approach based on a gaze-speech system for HRI tasks. This study used a mixed reality headset. In addition, we used the Baxter robot for the HRI tasks, as shown in Figure 1. 1 table and 6 cubes were used for pick-and-place experiments. The MR world has 2 holographic interaction modes: gesture mode, GM, and gaze-speech mode, GSM. Furthermore, each interaction mode represents 2 different conditions: big targets and small targets. Both big targets and small targets were virtual buttons with different sizes. Figure 1A and B represent the typical mixed reality interaction in HRI, using the gesture mode. The MR world displays 3D styles of holographic buttons: blue, pink, and green. Here, the subject uses hand motions as a pointer to navigate the MR world. Also, the pinch gestures aid the subject in selecting the holographic buttons and targets. Figure 1C and D show our proposed system, gaze-speech mode. Like the gesture mode paradigm, the MR environment shows 3 interactive buttons: blue, pink, and orange. All buttons, conditions, and sizes are the same as in gesture mode. However, the interaction process is different. The software recognizes the subject's gaze and speech command called select. We recruited 20 individuals and split the participants into A and B groups. Group A achieved first the gesture mode and then gaze-speech mode. Group B achieved inversely. Figure 2 shows the experimental design of this study. This experiment began with the interaction of the subject and the actual cube. The participants were instructed to press the blue holographic button corresponding to the current cube. The individuals were then required to locate and select the correct target from among the incorrect targets. Finally, the Baxter robot picked the current cube and placed it in the correct target. We evaluated each experimental mode under 2 conditions, BT and ST. In addition, we used the Fitts law equation as a reference. Here are the demo videos for both GM and GSM.
Select. Select.
All participants answered 4 survey questions at the end of each experiment. Table 1 shows the question of the survey. Furthermore, each question was based on a 7-point Likert scale. Here are all the hypotheses that we saw in this study. Participants using gaze-speech mode GSM will require less time to perform the experimental task compared to the participants using gesture mode GM. The subject's performance will be statistically similar regardless of their group. The participants will complete the experiments under the big targets conditions faster than the experiments under the small targets condition. The GSM system will have the highest safety perception. The GSM system will be rated significantly higher than the GM system in terms of time performance satisfaction. The GSM system will be the easiest system to use, and the GSM system will be the least physically demanding to use. Figure 3 shows the total completion time of the participants during the pick and place experiment. In both groups, the GSM system outperformed the GM method under PT in blue color and ST in red color conditions. In addition, we tested the hypothesis 1 to 3 using a t-test with a significance level of p less than 0.05 between each paradigm and its corresponding condition as shown in table 3. In general, hypotheses 1 to 3 were confirmed. Figure 4 shows each subject's average target-to-target time performance in group A and B. We determined all the RMSE values of the GM and GSM systems against the references in black and green colors. The average RMSE of the subjects using the GSM system was 1.5252 and 2.1433 seconds under the BT in blue color and ST in red color conditions, respectively. Figure 5 shows each participant's responses to the survey on a 7-point Likert scale based on the performance of the methods GM and GSM. One ANOVA test suggested that hypothesis 4 was rejected and hypothesis 5 to 7 were confirmed. Our findings proved an efficient way to improve the time performance in HRI with mixed reality. We showed a new alternative for time reduction based on the GSM paradigm. We will explore other input interactions in future works, such as VR handlers and haptic devices. Here are the references. Acknowledgement. Thank you for listening, and please visit my poster for further explanation.